Hi there, this is Jags Ramnaran again. So now we'll go through part 2 of the demo. Um, so in this part of the demo, we'll look at how to achieve interactive analytics where the data is in fact changing. So we use a technique called as CDC or Change Data Capture. For those of you who haven't heard this term before, this essentially refers to the technology that can capture transactions as they happen in databases, and it can route it to one or more endpoints. It's typically a use case for this would be to replicate databases essentially. Okay, so before we dive into this, let's actually revisit and refresh our memory on the problem we went through for demo 1. So like you know, all new data is often emerging to customer facing apps and captured as transactions in operational databases. From there, you'll end up going through classic ETL to other analytical databases, applying transformations. And if you're going to operate in the cloud, the data has to be periodically copied back out to the cloud. So like I said before, this is a fairly expensive process, very time consuming process. Often the data you're analyzing is stale, and so your insight essentially is also stale, right? So what we really want is to be able to capture changes as they happen and be able to route it to our analytical storage, right? So the most common choice today is to inject a message bus like Kafka into the application pipeline. And as you can see, I'll just talk through this. It's rather very difficult. So here is a typical streaming pipeline that you potentially see today. One example, I mean, there are many variations to this obvious architecture, right? As your application microservices, let's say, transacts with a database, say in this case Amazon RDS, your application might also route events to Kafka. Then the Kafka messages would have to be decoded by either using Spark Streaming, Flink, or you can substitute your favorite stream processor. And then finally write it out to your analytical store. If you're operating in the cloud, maybe you're writing it to S3, formatted in Parquet, or maybe you're just writing it out to a traditional warehouse like, let's say, Redshift. Well, there are a number of challenges here, right? First, well, how exactly can we achieve consistency if we're going to write as transactions happen both to Kafka as well as to our database? To essentially achieve consistency, you have to worry about two-phase commits, you have to worry about various failure conditions. And moreover, what happens if you land up changing the schema in one? Well, you have to consistently land up changing the schema in other, else you again land up having potentially inconsistent data in our analytics store. And finally, you have to write code that has to decode data objects from Kafka. Maybe the data was formatted as JSON, and storing it with consistency to your analytical store, which is again your responsibility. So the other challenges have to do with when failures happen, you might land up having the messages delivered twice. On top of that, if the events land up being DML events like updates and deletes, is rather very complex. So instead, what we're really proposing is using a design where your application essentially only works with your operational store, and you use CDC technology to capture the changes in real time in a transactionally consistent manner, and just keep pushing the delta continuously to our essentially snappy hybrid store. So it's a rather much more simpler, far fewer sort of pieces that can break, and even if anything breaks, everything can recover fully in a consistent manner. So the way we essentially accomplish this in our cloud platform is by deeply integrating with an open source platform from Red Hat called Debezium. It's really designed with using Kafka Connect. You can go check out debezium.io for a full understanding of what it does. But we have landed up essentially deeply integrating. So as I'll show you, this requires no application coding other than simple Spark-based transformation. If your schema that you use for analytics lands up being different than what you have in an operation store. I won't be getting into details of how exactly all this works. But one important point to note is that the CDC engine uses Kafka Connect to tap all the committed transactions in let's say if you're using MySQL and sort of bin log, and that's what gets pumped to your destination. So essentially what is guaranteed is that you only see things that have in fact completely been committed in your transactional store. And you essentially land up maintaining source ordering, which is a big plus compared to, let's say, if you land up just using Kafka.